We'll finish chapter 5 today. Chapter 6 will take maybe 40 minutes. That's a very simple, chapter or module, but it's very tricky because you have the unit convergence between metric and then the SI system, so or English system to metric and vice versa. So let's finish this chapter 5. We might not be able until maybe Wednesday because that's too long, this chapter. So we'll do a mole. Definition of a mole. Now there is an animal called mole, looks like bigger than a squirrel, and that has nothing to do with our mole. The same spelling, the same pronunciation, the same thing. However, the mole is an animal, has nothing to do with our chemistry mole, correct? The mole in definition here in chemistry has a lot of definitions, and you can memorize all of them or make yourself a piece of paper and write them there. So what is, let me just back up a little bit. I say 1 mole, okay? 1 mole. 1 mole is Avogadro's magic number, 6.022 10 plus 23 molecules. The mole is again 6.022 10 power plus 23 atoms. 6.022 10 plus 23 formula units, or sometimes we call them ions. So units, or we call them ions. Now this is by far is this Avogadro's magic number. By the way, those are experimental values. So he measured, he used gases, different gases, and every time he comes up with this number. So this is honored by his number, Avogadro's number. I did not see his name honored in the periodic table as yet. Maybe in the future we'll see his name. There's a lot of scientists' name. Somebody will tell me, where is Rutherford? What? Rutherford. What the Chad was the atom is made of? 104. Atomic number is 104. Einstein, where is Einstein there? Where is Einstein? Somebody will tell me where is Einstein is. Einsteinium. Oh, at the end IUM. This is, but the name is Einstein. Where is Einstein? Somebody will give me where is Einstein? Is in the lanthanide and actinide. What's the atomic number? Somebody has Einsteinium. Einstein. No, it's inside. Just look at it. Just take your time and look. So you have how much? Yes, 99. How about Madame Curie? That's discovered the whole isotope, the whole thing with the isotope activity. Where's her name honored to? 96. Can you see her name there? Curie. IUM at the end, that's added from Latin. This to give you the name. Okay, so you can see a lot of name of other scientists are there. So, but anyway, so he did not. He was not honored yet, but although his contributions are, or were until now are very, very excellent. So now we had this relationship, we extend this relationship. We say 1 mole by definition is mass, a ratio between mass and molar mass. And we will say the mass as is does not change. The molar mass is the sum of all atomic masses of the elements, or of the matter of the elements involved. Okay, guys, so that's the definition of the molar mass. What's the molar mass? Molar mass is the sum of all atomic masses of all the elements involved in the compound, in molecule or compounds here. Okay, guys, can we extend this one further? Yes, no. Somebody will tell me what's the definition of a mole. Yes, we can. We can even say, okay, so by definition, that's the first thing is done. That's 1 mole is the 12 grams of carbon-12 isotope. So if we have 12 grams of isotope carbon, this is carbon isotope here. Okay, guys, so you can see that we have how many definition? Make sure you have a picture of this because that's not in the PowerPoints, and it comes, even the final exam will not give you all these numbers or all this stuff. Maybe Avogadro's number, but all the stuff here will not give you. So a mole, 1 mole is equal to Avogadro's number of molecules, atoms, or formula units, or ions. And the mole is the ratio between mass over molar mass. And really, a mole is really 12 grams of isotope 12. Of the isotope carbon-12. So that's the definition of a mole. So let's do some, before we go, we define the molar mass, correct? Let me go further. Can I take this one out? Everybody has it? Take a picture of it. If you can't catch me because I'm a little bit faster, so you can take a picture of it. Feel free, so take a picture of it. And you can record me. I have higher chemistry principles. Students, they can't catch because we have in the background of the lab, it's too noisy with the hood. So they put a lot of their cell phones to record me. That's fine. You can record if you feel you want to record, but you have it already as recorded here. But it's up to you. You can record me. You can take pictures. You can take anything. But make sure that this is not in the PowerPoint. As I told the other class, the higher chemistry ones, I cannot put everything in one PowerPoint slide. Can you follow me here? And it's better to come to the class. You can get a lot of information. That's what I did in Germany. When I was a student in Germany, undergraduate, then graduate, the grad school, you have to attend. The professor said you have to attend because some of the professors, they have their own books published. We study their books, but even in their books, they did not write everything. They did not write everything. So you have to come, and then there's a lot of information. It's not in our ebook. Go to ebook, you'll not find all these details like this. So, but that's the way we have a lecture. Lecturing means you give something not in the ebook, something not in the PowerPoint. So that's for your own benefit. So anyway, so let's take this one out and look at, before we go further, just another definition we have to say. That's we talked about this before when we came to the nuclear chemistry, I think, but I'm just putting this one back. 1 AMU, we talked about this, that's before, is 1 gram per mole. 1 AMU, what stands MU for? A, atomic, correct? M is mass, correct? And U is unit, correct? Atomic mass unit is 1 gram per mole. I'm bringing this one back from the previous chapter. This is a molar mass. Why is a molar mass? Because it is a ratio between mass in grams, correct? Gram per mole. That's what and then you have the molar or atomic mass. So just I'm bringing this one back just for you to recognize that when I say 1 AMU, I'm talking about really the molar mass. AMU is a molar mass, correct, guys? So this is it. This is it. So let's go and look at some examples here. And everybody has this. Take a picture of it. You can record me. You can do whatever you like. And as I said, the exam 2 is open book. I'm repeating myself because the higher chemistry ones, they were one couple of students, they did not realize. If they don't come to the class, then I can't help them. So if they don't come to the class, because we say a lot of stuff, we discuss a lot of stuff, it's not inside the recording or inside somewhere else. They took their quizzes and exams, they did badly because they thought that's a closed book. And they missed a lot of questions because they did not know what the formula that they have to use. Well, this I'm repeating myself for that trillion, gazillion times. It's an open book. You can bring everything you want except the cell phone. Please. Everybody is listening to me? Don't come and complain that Dr. I did not know. So if you come, you will know. If you don't, that's your problem. It's not my problem. So it's open book. You can use anything you want except somebody's help using your cell phone. Okay, guys, let's take this one out. And now I'm going to, you tell me how to get worksheets. So I need help here, your help. We talked about this before. I need to get a worksheet. Psychology, biology, history, fine arts. I need to get what? What should I do first? What should I? The topic first, correct? What's our topic is? About the mole, correct? Avogadro's calculations. Let's do Avogadro, mole calculations. Let's do mole for calculation. Mole and Avogadro's, see, is the numbers already there? Avogadro's calculations. Now, if plus, you don't have to do plus, but plus is very good for Google, for search engine, that you have to add this. Now, if I'm lazy, I put the answers, correct? Not lazy, but if I want to reconfirm myself that I'm doing the correct one, then I write what? Answers. So then it will show me all available worksheets, the answer. But did I add the worksheets? We did not. Then the second thing, that's the topic. We did not add the keyword worksheets, correct? Plus answers. Now I said this answer, I'll take it out, correct? You want the answer? It's not good because it does not show us. We have to depend on ourselves for the time being, So let's see, worksheet without answer. So now they have, Google have this artificial intelligence. The first thing in Google will come this AI. Can you see it in the top? That's, don't forget, forget about it. Sometimes it's correct, sometimes it's not correct. What this artificial intelligence does, somebody will tell me? It gathers all the search engines are available on this global universe and then try to connect them with the same keywords. That's all. Goes to Yahoo search engine, to go to Microsoft search engine, Google search engines, all search engines, and combine them and see what the keywords, and then put you an abstract there. That's all. It's nothing. It's making itself from nothing. No, there's just going. That's what it does. Okay, guys. So, and if I turn this AI, instead turn it in our software to check copyright, this AI will fail because most of that stuff is taken out from what somebody else search engines, correct? So let's not bother with the AI, artificial intelligence. Let's go for, we have Clayton school district, that's high school. Amazon sells worksheets. Can you believe that? It does. Amazon does sell, but don't buy. There's too many good professors out there. I intend to do that so when I retire. Some of those professors are retirees. They just write those for free and then post them in the website. So Avogadro number, the mole and Avogadro's number. The Weebly one is again, it's like a free And those free organization, those are non-profit organization, by the way, non-profit organization supported from outside funding. So, well, he has given us the answer, so I don't need the answer. So that will not help us. So I need one without answer. Let's do this one here. I hope without answer. Yeah, this one without answer. The answer is below. That's good. Then we can do some of those here. Okay, and let me take snipping tool here. Let's take convert moles. Okay, so here it is. We'll do those here. Copy them. Again, there are too many out there, so you can just search, but I don't have time to get the detailed search, but at least for our purposes will work. And I have, so this one here. Now, with this in mind, there is a rule for the calculation. So we are going from, for example, we are going from, we can't go for this Avogadro's calculations. We can go from the mass in grams to molecules. Okay, as this is given and this is asked. So in order to do this, we have to do we have to obey some rules. So if I have the mass given and the molecules or atoms or ions are asked, then I have to, the first step here, divide by molar or atomic mass. Take the, oops, sorry. Let me take this one out for the time being. Then I'll bring it back. I still have it in the snipping tool. So then number 2 here, you divide by the molar mass, gram per mole, or by atomic mass. Number 2 is multiply by Avogadro's number. Okay, guys, and this is asked, correct? So the number of molecules or atoms or formula units which has those ions will be very large. Will be very large. Guys, everybody has this first rule. So we'll take a gram of the, we'll come here and then take one of those here, examples here, the worksheet. Somebody has this? Everybody has it? Okay. So let's look at this. Yeah. So take a picture of it. Everybody has it? So just taking convert to number of moles. So we have, we'll take grams into, yeah, we'll take one of those here, to moles and to, can I take this one out first? Let me just, hold on guys, don't be confused here. Can I take this one out? First rule. So let's take one of those here and we'll extend it. So which one you like? First we'll take the mass. We'll convert those atoms to the mass. We'll take 500 grams or 0.005 grams neon, number 10 or number 9, or we'll take the mass and then we'll convert it to moles, and then for moles into what? Into atoms. So which one you like? We'll take from the 6 to 10. Which one? Which one you like? 6 to 10? We'll take those here. One of those here, the masses. Which one you like? Any preference? 8. 8 is 98. I'll write it here, 98 grams sodium. So let's minimize this. Let's minimize this and then 98.9. So take this one out and write it here, 98.9 grams of sodium. I need to know how many molecules does this grams. Like this stylus here, I have this stylus here. So I weigh, so say maybe about 15 grams. How many the polymer inside, how many carbon atoms inside this? I can calculate using Avogadro's number. So I'll show you in a minute how we do that. So 98 gram, I want to go to molecules. How many molecules in this? Well, I have the first step here. If I given the mass, I have to divide by the atomic mass or molar mass. So I have 98.9 gram of sodium. I can do it by parentheses or brackets or by table like this. Sometimes the table is very obvious. So here it is. Then I say, okay, sodium is 23.0, correct? Where is sodium? In the third period, correct? Atomic mass 11, and more atomic number is 11. Atomic mass is 23, correct? I'm just rounding it whole number. So 23.0 atomic mass always will end up with grams. 23 grams per 1 mole of sodium, correct? This way here, I got rid of the gram of sodium with the gram of sodium out. I have mole of sodium, correct? Now, that's the first step. First step. You divide by the molar mass. The molar mass is this number here. You divide by the molar mass. The second step is, then I have to put, by definition, 1 mole of sodium is Avogadro's number of sodium molecule or molecules. Okay, guys, so now we have here the mole of sodium out, the mole of sodium out. Okay, guys, so the only unit left for us is, the only unit is left for us is this one here. Oh, sorry. Is this one here. That's what we are looking for, correct? So now we have to watch what? Somebody will tell me? I know it's Monday today, I can understand, and it's a Columbus Day too, so people are in holidays mood. So how many sig figs we have? What we have to watch now? Before we do any calculation, we have to figure out our answer to be rounded up to the correct answer. This is how many? 3 sig figs, correct? Yeah, before you do anything, you have to determine what's the outcome. This is how many? 3. And how many here? 4. We said the power has nothing, it's not part of the sig fig, so 4. So our answer has to have how many? 3, correct? 3, 3, 4, 3 is the least one. So now I have to multiply this by this, divide by this. Now let me show you something that students have made and will make, and you will make, I mean, with the calculator, That's a big issue with the calculator. The power 23. So I will isolate the 23 by itself. It's nothing happened. I will ignore it for the time being. So I will multiply 98.9, divide by 23, multiply by 6.002, and then round it off to 3 sig figs, and then at the end multiply by 10 power 23. That's the best way. If you sometimes write the whole number in the calculator, you might get an error. So let me do it here to show you, then you can follow my steps. I mean, it's up to you. You do whatever, but I can't guarantee you will make a mistake with the power, with the exponents here. So I'll take 98 here, 98.9 multiplied by 6.022. I'm ignoring the power. Equal, divided by 23.0. The answer is 258946. I'll write it as is. Whoops. Well, I can copy it as well. So let me copy it here. So I'll copy it. Right click, copy, and then put the answer somewhere here in the top just to see it. Yeah, so I have it here. So the answer is here. Answer is what you say, 25 point. I need 3 sig figs, correct? So now I have here 8, correct? And after 8 is what? 9. So the one will be coming out is 9. Is this the answer? No, I left this one here out of my consideration. Multiply by plus 23, and the units molecules. Everybody follow what I did? Did I put the power 23 inside? No. It is always issued the students, they by mistake they put the 23 and they get very strange answers there. So that's the answer here. Okay, guys? So let's take this one out and then we'll reverse. Now these molecules can be ions too, can be atoms. All this is the same procedure. Instead of molecules here, you can write ions or you can write atoms. The same thing, correct? So now let's take the other one. Can I take this one out? Everybody has it? Okay, good. Let's take it out and let's do the reverse. Now we have 25.9, correct? 10 power 23. Let's do it the same thing. So we know it's 25.9. So let's take this one here and take this one here as well out. So let's take this one here out. Okay, now we are going from 25.9, correct? 10 power plus 23 molecules or ions. That's the second rule here. Second rule. Or atoms. And we have to get the mass, grams, mass. Okay, what's the rule? The rule is, will tell you, you have to divide, step number 1, divide by what? Avogadro's number. Divide by Avogadro's number. Correct? Number 2, you have, when you divide by the Avogadro's number, you get the molecules, ions, or atoms out of your way, and then you have to multiply, opposite what we did before, by the atomic or molar mass. Okay, guys? Are this following? Okay, so the opposite what we did. So now we are going from molecules, ions, atoms into mass. So Everybody has this? Everybody has this? Okay, can I take it out? Okay, so let's take this one out and then put this one. This is the rule here, the opposite from the first one. So now I'm going for 98.5 10 power plus 23 sodium molecules, correct? Into grams, mass. This is the mass here. Okay, how many grams of this molecules work grams? Well, the first step we'll do the same thing we did with the table here. 10 power plus 23 sodium molecules, table here, over 1. We have to divide by Avogadro's number. Avogadro's number is 6.022 10 power plus 23 sodium molecules. Per what? Per 1 mole. That's the definition. Correct? Now, with this step here, we have gotten rid of what? Of sodium molecules out of our way. And we have the unit of mole, correct? We have unit of mole, which, that's a mole here. And then I can even get further. The exponent 10 plus 23 here, and another one here. This one here with this one out, correct? Next is to multiply, according to the rule, by the atomic mass of sodium. Gram of sodium, correct? Per mole, this is sodium here. Okay, mole of sodium. So here it is again. You have mole of sodium cancels out. Okay, guys, so what's the only unit left is your, that's sodium grams. So then you will do what we started with when we started with 98, correct? We should have this one here. If I go there, and we can make this one reversed. I can do the history, see what the history is. You can see the history what we did. So we started with, that's the history with that. So okay, guys, let's close the history here. Here it is, 9.8, guys. 98. 98.5 divided by the Avogadro's number. The 10 power 23 is gone. 6.022 equal, and multiplied by 23.0, and the answer is, the answer is not correct. What's that? That's what you got? No, that's not. Yeah, that's not. Just cool yourself down. We'll get it. So, unless we did something a mistake. So, 98. Let me take it again. 98.5. Was it? That's the beginning of the 98.5 divided by 6.022. Okay. Multiply by, now that sounds very good, 23. It came out the same thing. So anyway, so 3. The first answer we did, what came out to be? Same number? Yeah. Okay, so let's see. So it came out to be 376.2039 grams of sodium. Now, with this in mind, We need how many sig figs here? 3 and 3 and 4. We need 3, so it will be 376 gram. Yeah, without 3 points. So that's not 5. So gram of sodium. So that's the answer here. Okay, guys, everybody knows. Now let me show you something here, and that's sometimes comes in the final exam. Very strange, but it comes. So now I'll show you an example here. Sometimes for some reason they bring it. It's higher chemistry should not be there for survey, but let me show you here. Can I take this one out? Everybody has it? Take your time. Everybody has it? Okay, let's take it out. Now I'll tell you something here, guys. I will have I will give you H2O now. We are dealing with element. Now I have H2O, that's a molecule, correct? H2O. Okay? And I will take 5.50 gram of H2O. I need to know in this 5 grams of H2O how many hydrogen atoms are present. Are you following me here? That's you have to watch. That can be brought in the next quiz, because sometimes they give you on and off this all of the sudden from nowhere. Although that's a little bit more elevated chemistry, but at least we can do it. We can do it. So now you have H2O. You tell me in this molecule H2O how many hydrogen atoms? How many? 2. And that's the key. That's the key. But don't tell me that it has 2 atoms. 2 atoms. No, that's you have 5.50 grams. Correct? So let's do it together here. Do it at the table, or this time without the table. Let me do it with the parentheses so you can know there's 2 ways. You know that there are 2 ways. So I have 5.50 gram H2O, parentheses, multiply by, I have to multiply this one here, not multiply, by divide by molar mass, correct? I divide by the molar mass. What's the molar mass of H2O? That's a molecule, correct? So what's the molar mass of H2O? Somebody will tell me. We have 2 hydrogens plus 1 oxygen. 2 atomic mass of hydrogen is 100 gram per mole, plus oxygen is 1 multiplied by 16.0 gram per mole, correct? So this is 18, I would say 18.0 gram per mole. So this is the molar mass of H2O. I need the gram to cancel with the gram, so I put the gram H2O at the bottom, correct? 18.0 and per 1 mole of H2O. I divided by the molar mass, but this time molar mass of a molecule, not atomic mass. Okay, guys, so with this step here, I get rid of units. Grammar always watch the unit. So next is I need to get number of atoms in this 5.5 grams. So I'll be using, correct, 1 mole here of H2O as Avogadro's number of H2O molecule, correct? So therefore I have this mole H2O, the mole H2O cancels out. Now here is the new step we have to introduce ourselves into it. So now I have here molecule, correct, H2O. I don't need molecule H2O, I need atoms. So I will say I have 2 hydrogen atoms in 1 molecule, 2 atoms in 1 molecule of what? H2O. correct? That's what it says here. Okay, so this is the step here. This is the new step here you have to add. So this one here has to be multiplied. Correct, guys? So I have the molecule here, oops, the unit, sorry. I have the units here out, molecule H2O, the molecule H2O. I have the units I want, which is hydrogen atoms. Now, I take this one here, divide it by 18, multiply it by this value, and multiply it by 2. Okay, let's do it together. If somebody has it, tell me, so I'll take your answer here. How much is it? No? Well, let's do it together. Again, am I introducing the am I entertaining the power 1023? No. I'm not using it. I'm not entertaining. I'm not doing anything with it. So just leave it as is. That's I can avoid any mistake in the entering this into the calculator. This is really a real issue there with the students with this 10 power 23 through the years. Through the years. So what I will do with this, I will take 5.5 and then we'll do the sig fix. 5.5 divided by 18 equal to this, correct? And then multiply it by 6.022. Leave the power alone. Don't touch the power, correct? And then multiply the whole thing by 2, correct? Multiply by 2. The answer is 3.6. So the answer is, let me just write it here somewhere, 3.680. So we need how many sig fix? Now, don't come to the idea that's 2 here, 1 sig fix. You have to understand this, please. This is not part of the sig fix. The same thing with this whole exact number is not part of the sig fix. Always sig fix, if you have no decimal at all, then the whole numbers are part of it. If there's no decimal here at all, then all of them whole number, then yes. But here you have decimals. So this is whole exact numbers, not part of it. Your answer is not 1 sig fix. This is 3 here. This is 3. This is 4. Your answer has to be 3. This is not part of the sig fix. Are you following me here? Is this following? So the answer is here 3.68, correct? So the answer is 3. Let's write it here. 3.68. Is this the answer? What's missing? Yes, that's the power. We can still leave it alone. Plus 23, and the unit is atom, hydrogen atoms. Correct, guys? So watch out for within the molecule will tell you how many atoms within the molecule. So you have to watch. Get yourself first the molecule, and then see the ratio of the molecule, this atom inside the molecule, how much is it? Correct, guys? So that's what you see how many atoms in this 5.5 grams H2O. Okay, guys? Any question you have? Any question? Okay, good. So can I take this one out? Everybody has it? So next is we will go for limiting reactant. Okay, we'll go in the chemical reaction. So we'll go in a chemical reaction here. Can I take this one out? Okay, I'm taking this one out. We'll be looking at the chapter 5. Okay, and we did all this here, determination, mass, mole, chemical in the chemical reaction. So this is example. Sometimes they give you chemical reaction, and I can take this one here, snip it, and then I'll tell you how many grams. So here it is, and then we'll solve it together. How about you having this within chemical reaction? So take this one here, copy, And so we are copying this, copy, and we have to hold on, copy this one here, and I need the layout to be a little bit less. So yeah, that's good. So I'm pasting the whole thing. Here it is. Now we have a chemical reaction. Now, you remember from last week, this is what? Reactant, correct? This is what? Product. Now, this is the separator here, arrow. So this is not reversible. If you have two double arrows, that will be reversible. This is not reversible. So, and what type of reaction is this? And I put for you here, this is potassium all soluble, AQ. Barium is AQ. And this is solid. This is AQ, aqueous. So, you know what AQ is? AQ means, did we have that before? Yes or no? AQ means aqueous, soluble in H2O. AQUEOUS. S means solid. And G means gas. L means liquid. So, now, it gives you that you have 14.3 grams of potassium phosphate. So, let's take this one out. I'll put some numbers underneath. So this one, or we can put it in the top. So this one here, potassium phosphate is 14.3 grams, reacting with barium nitrate, correct? To give you barium, this is a solid, correct? So solid, this is solid here, plus sodium nitrate. So, and it's acting, what will be, for example, what will be the amount of the yield? We can the yield obtained, yield of potassium nitrate. I mean, we can change it. We can say the yield of this solid. In the matter of fact, in the real lab, you will determine the yield of this. But it's up to us. You like the yield of this or the other one? Which one? We can determine the yield of the two products separately. Which one you like? The barium phosphate or potassium nitrate? Which one? It does not matter. I like the 6 because this ratio 6 is good because we have to look at the whole ratio. So we'll take potassium nitrate because of the 6 moles in front. Okay, guys? So can I take this one out? So we'll calculate what is the yield of potassium nitrate. That's what we are looking for. Okay? So can I take this one out? Already has it? That's a chemical reaction. What type of chemical reaction is this? Can I take this one out? Everybody has it? Everybody has it? Okay, what type of reaction is this? It's coming in the midterm, I think. So what type of reaction is this? What's that? Don't be shy. I heard something. Double. Why is double? The answer is correct, but it was a little bit with hesitation. So we'll see. We'll throw the answer. We'll see what might be correct or not correct. So potassium here will take over what? Over the nitrate here. Correct? Potassium will take over the nitrate. And the phosphate here will be taken by barium. So this one here, and the other one is, that's potassium here with the nitrate. That's a double. They swap their anions with their corresponding cations. Swapping partners means the ions will get, of the first one will take the first cation and then vice versa. So they swap their ions and the cations. Okay, guys? So this is double. Whoever have not taken the midterm yet, Monday class, um, there is a question about those type of reactions. So make sure that you understand this double double displacement or replacement. So whatever you like, or replacement. Sometimes some textbook like replacement, some textbooks like displacement. That's the same meaning. Synonyms. Those both are synonyms, meaning the same thing. So we got the whole thing here, and we have 14.3 grams of potassium phosphate. So can I take this one out? It has it? Okay. So it's given to us that the potassium phosphate, this one here is 14.3 grams. That's your starting material. And you want to get out of this one here, we'll learn later on. This is limiting here. This one excess. We don't care about how much is present. So, but how much we need the yield of this. So, let's start with 14.3 grams. If I start with 14 grams, I have to know the molar mass of this compound. So, molar mass of K3, because you have to get rid of the grams. And whenever you need get rid of grams, you have to go through molar mass. So molar mass of this potassium phosphate. So 3 potassium, 1 phosphorus, and 4 oxygen. So 3 multiplied by 39.0 gram per mole. Check with me. Potassium how much? 39.0 plus phosphorus how much? 31. Look at this, 31, correct? I'm rounding a whole number, gram per mole. And oxygen is 16. It's not 16, 15.999, but I'm rounding it to whole numbers. That's fine. Gram per mole. So 3 multiplied by 39 plus 31 plus 4 multiplied by 16. So I have this one here is 424. 64, correct? Is it 64? This is 27, 9, 11. So let's see. Molar mass, you have to add all the atomic masses of each element involved in this molecule with its corresponding amount. So 3 means I have 3 atoms of potassium. So let's do it here together. I have 3 multiplied by 39 equal 117, correct? And then I have 16 multiplied by 4. 16 multiplied by 4 is 64. So 64, so let's see, 117 plus, yeah, it is 17 plus 31 plus 64. All those, this one here with 1 digit after the decimal, so we put this one here. This is 0, this is 0, this is 0. So how much came out to be? 212. 212. Can we check this one out? You can Google the molar mass of this and see if we did very good job or not. So gram per mole. This is the molar mass of this compound. Can I Google that? Yes, I can. So let me just Google it and see. First of all, let me just take this one out here. Everybody has this? So we need the molar mass of this. And then we need the molar mass of potassium nitrate. Potassium nitrate. So somebody has it? Potassium nitrate. Molar mass of potassium nitrate. Because You need number of grams. So you have always, whatever is the reactants, whatever the product molar mass, they have to be ready. Molar mass. This is the product. This is the reactant you put in. And that's what you are calculating how much. You cannot do this unless you have the molar mass. 1 potassium, 1 nitrogen, and 3 oxygens. Correct? 1 multiplied by 23.0, not 20, 39, sorry. 39 here. Let me out. Oh, don't worry about 0.1. Don't worry about it, because in the lab we just round the whole thing. 39.0 plus 3 multiplied by 16. So 16 is 48, correct? And 39, and then I have nitrogen is, how much nitrogen? 1 nitrogen is 14, correct? So 39 plus 48 plus 14. So let's see. Everybody has this one here. How much is it? 101? 101 gram per mole. So just double check you, because today is Monday, we have to double check that our calculation is correct. So I will, can I take this one out? Everybody has it? So we have 101 here. Whoops. So let's see here. We have 101 here for potassium nitrate and 212 for the potassium phosphate. You need, whenever it comes in a chemical reaction, you need the molar mass of both. Of the reactant you are starting with, and the product you are, your goal to get the amount of yield of it, how much I will get out of it if you use this amount. Everybody has it? Yeah, can I take it out? Take it out? Everybody has it? Okay, so everybody said yes. So now let's go and look if we are doing correct or not. So I will say first here, molar mass of potassium 3PO4. Came out. Are we okay? Don't worry about after the decimal. They have not that much effect in the lab when we work in the lab. So 2 to 12 is good. So that's good. Don't worry about it. It's not, if this 12.5 point decimal 5, then we have an issue. It would be 213, but it's not. So we did very well. So how about potassium? We said 101. Potassium nitrate. Let's see. We have to check because today is Monday, correct? 101, that's correct. So our calculation both are correct. So, and that's very good. Very good sign that we are still awake. So, let's do now the calculation. Let's do the calculation here. Let me get this one here. And we'll do the calculation together. So, we need the yield. We need this yield here of this, the yield. And this one is product, correct? Starting material is 14.3 grams. Starting material, correct? Potassium phosphate. So we have 14 unit. Let's make it table. Let's make it table here. And there's parentheses or tables, so it's up to you, whatever you prefer. So here it is. I'll make table. So it is here, whatever here. So I have 13.3 grams potassium phosphate. Maybe I have to make it much better here. So I might change the. Okay, so the molar mass of this we decided to be what? 12. I have to divide because I have to get the grams out. 12 to 12O gram potassium phosphate to mole of potassium phosphate. Okay, so with this type of calculations, I have gotten rid of the grams with the grams out. Correct? You divide by the molar mass. Molar mass always starts with the gram per mole. Gram per mole. I need to get the grams up underneath to cancel it with the gram I started with. So then I have here, the big issue here, I have to look. Mole of potassium phosphate. I might take this one here out too. Write it here. I have more space for it. Mole of potassium phosphate to mole of my product, potassium nitrate. That's my product. So then I have to have the so I have to look at the equation here. Then I have to look at what? The equation. The equation tell me what? Here is 6 and here is what? 2. I have 2 mole of this to 6 mole of this from the equation. So this is divide by molar mass. And this step here is mole ratio from the equation. Mole ratio from chemical equation above. Okay, guys, now I need to get the molar mass of my product, correct? Well, the molar mass of my product is we said 101, correct? 101 always gram, remember, gram of potassium nitrate to mole of potassium nitrate, correct? So here it is. Take this one here out. Oops, sorry. Okay, guys. So with this in mind, I have to cancel units. So let's cancel some of those units here. I will say around here. So the gram with the gram cancels out, correct? And mole of this will cancel with the mole of the other one, correct? Mole of that's the reactant. Mole of the product with the mole product cancel. I get only the units of gram potassium nitrate. That's what we are looking for. That's what we call it the yield. So now this one here, the next step to watch for what? For what we say? What we said? Sig figs, correct? Don't forget. This one, how many? 3 sig figs. This one, how many? 4 sig figs. This one, absolute values, they are not part of the sig figs. Since we have all decimals here, decimal will take over, numbers will take over rounding off of the answer, not the whole exact numbers. So those exact numbers, so leave them alone. This is 4 sig figs. Our answer will be how many? 3. So this is the least one. This is the least. So it has to be rounded to 3. So now, let's do it together. We don't have Avogadro's number to worry about. So I'll take 14.3, multiply it by 6, multiply it by 101, divided by 212, divided by 2. So let's do it together. See. Somebody has it? Somebody has this? No? Okay, let's do it together then. Okay, guys, let's do it here so I can see it much better. So this number, sorry. So here it is. I can see it now. So 14, guys. Let me just make sure that's everything empty. 14.3 multiplied by 6 multiplied by 101, okay, equal to this, divided by 12.12 equal this, divided by 2. and it came to be what? 24.3. I need 3 because the 3 here, correct? Look, guys. That's the answer here, guys. Insert box. I'm trying to insert the box here, but anyway. So I can put the number here. So paste. That's my number here. Okay. So this one here equal to, let's take this one out. This is the answer here. The answer is grams, correct? Now what's my answer will be? 21, 21.4, correct? Gram of potassium nitrate. Now, if I want to do the other one, let's do the other one, but I'm not calculating. Let's get the molar mass. Just a little bit lazy. We'll do the other one. Let's do the how much we get out of this 20.4 grams of potassium nitrate. Let's do this one here. We'll replace what? We'll replace the molar mass of the potassium nitrate with the barium phosphate. Let's do that. And I will do it here. Just Google it, correct? Just a little bit lazy. So just a little bit. Barium 3, and then PO4 2. How much is it? 602. I'll put what? 601, but I put what? 602. So that's good. So now, everybody has this now? How about if I do it now? I say, okay, let's examine how much that if I do the other one. Okay, so I'll put here 6.02 gram of barium phosphate per mole of what? Of barium phosphate. So that's you need to change, and then you have to watch for the ratio. I have 2 mole here. We'll stay 2 mole here. That's the 2 always. But here I have how many? Not 6. I have how many here instead? 3. Correct? So let's calculate this one here. Let's see how much is it. Okay? Instead of 6, I have 3. Correct? That's the 3 here, guys. That's the 3 here. Not 3 here. The barium, what we said, barium sulfate is 1. Sorry, this 1. Not 3, this one here. This one, not barium nitrate. This one here. So this one here will be is 1. Okay, so it's 1. So 14.3 multiplied by 101 divided by this divided by 2. So let's see how much is it. So I have here, let's take it out, and this 14.3 multiply by 1, of course, multiply by 602. 602 is this amount divided by 12, 2, 1, 2. Correct, guys? And the answer is this one, correct? And this answer is this, and then you have to divide by what? By 2. What the answer came out to be? Check it out. Divided by 2, correct? Is equal to how much? 22.3. So it's 22 point what? 20.3, sorry. 20.3 grams of barium 3 phosphate. 2 here. Okay, guys? So it looks like very close they came. The answer is 2020. That's a little bit of I say it's we have luck in this. I'm not superstitious, but not always they come the same year. Okay, guys. So we calculate both. Just you change the molar mass amount, and we get the ratio here. The ratio of this is 1. So this is 1 here. So we know 20. Let's go and look at the PowerPoint. They may have the answer of one of them, of one of the products, whether barium phosphate or potassium nitrate. Can I text one out? Can I text one out? It looks very terrible. I apologize, but too many. But at least you get the idea. You are following me. So let's text one out, and let's go to the periodic to the this one here. We can take it out too. So time is up. This and time is up for this one too here. So let's go and look what they have in the. So can you see that they have 601.94? So let's see if they got the answer. How many? But they did not have this. Oh, they did not finish it up. But we did finish it up, and we did really yeah. So they did barium sulfate, and they did the other one. They did what? They did from the barium potassium sulfate to get the barium sulfate. So we did. So they did mole to 1 mole of this. Yeah, that's wrong. Somebody will tell me why is this? Okay, 1 to 1 mole ratio. 1 mole of this. Barium sulfate related to what? To potassium sulfate. Well, check it out. I think our calculation is correct. Our calculation is correct. So unless we did a mistake or something. So here it is. Next is to know what is the limiting reactants, correct? So you can look at the whole thing here, but we are looking at something called limiting reactants. Okay, guys, let's look at something called, we have still 2 minutes. Cool yourself down here. Cool yourself down. We have still 2 minutes. We can go to the center and get coffee and come back. So, we have something called limiting reactants, and then I'll let you go and finish this chapter. Limiting reactants. What do we mean by limiting reactants? Well, if I have A plus B, I have C plus D. After finishing the reaction, the SB is consumed. There's nothing there. So A went to D. So anytime limiting reactant, the reactant is that consumed 100% during the reaction. So reactant, that's reactant, that is being consumed 100% during the reaction. And we'll go and look at some examples here. Correct, guys? Okay, guys. And that's, I'll give you 1 minute, so next time you give me this minute back. Correct, guys? Okay, remember that. Coming Wednesday, you'll give me another minute back. Okay, guys, so that's it. Today, whoever with me in the lab, there is no lab today. Monday's lab, there is no lab. Finish up your midterm.